Today we are going to talk about rationalizing the denominator. See if we can remember how to spell that. Woohoo. And we're going to talk about it in terms of radicals. So things like where it's the square root of 5. That would be a radical. We need to look at certain properties of what a radical is. What makes this special, and how to sort of get it out of its thing. Let's look at a few things about that first. So let's start with some square roots that we do know. The square root of 4, most people know, is 2, because 2 times 2 is 4. So the square root of 4 is the number that I multiply by itself to get that initial number. And yeah, that's what it is. Let's try one more that we probably know. The square root of 9, most people know that is 3. 3 times 3 is 9. Now it turns out that most of the numbers you can't do that so nicely for, and so things turn into ugly decimals or other things, like the square root of 3. Here's a good one. There is no number that we have that we go something times itself is 3. We just don't have that. So what we really talk about it as the square root of 3 times the square root of 3 is 3, because it must be. We said the square root is the number by which we multiply itself to get that number. So to properly write the square root of 5 would be the square root of 5. Pretty unexciting, right? But we're going to look at this part a little bit more. Let's take a second with that. Remember that, we'll clear out some stuff here. Make some room. So let's look back at that. So like, let's say I have the square root of, I don't know, 7. Multiply it by the square root of 7, I will end up with 7. If I want to get the square root of x out of the square root of x, I multiply it by the square root of x, and I will get x. So it works every time by the fact that this is property in of itself. So square root of 19 times the square root of 19 is, you guessed it, 19. Woohoo! How very exciting. So we're going to remember that. Well, when we're just talking about square root, it's not too big of a deal, but a lot of times you're going to have a problem when they're going to talk about rationalizing the denominator. What does that mean? The denominator is the denominator. It's down at the bottom, right? So we're going to put a square root at the bottom, like the square root of 3 maybe, and any old number at top, maybe 4. We don't like having this down there. It comes from the past where this is kind of this is division, so we're dividing the square root of 3 into 4, and if you're to do that by hand, it's very, very arduous. We would rather divide a 4 into the square root of 3, because it's much easier. And so these wily mathematicians, they just go figured out how to fix that problem. And we utilize that for other things now, and to be in proper form, we don't like it in the denominator. And what we're going to do, remember, the square root of 3 times the square root of 3 is 3. Also remember that, I don't know, anything times 1 is that thing. All right, so x times 1 is x, 8 times 1 is 8, we know that. And also that any number divided by itself is 1. 7 over 7 is 1. Question mark over question mark is 1. Yeah, that's just what it is. Pretty straightforward, right? We need to utilize this, this, and this. We're going to erase the rest of this jibber jabber. Make it a little less confusing. And we're going to use those properties. So let's go back to it. So we're going to say, we already know that the square root of 3 times the square root of 3 is just 3. I want to multiply this times that, and I can do it by multiplying this times 1, and I can make this a 1 by just putting that there. So this is 1 for any number times 1 is itself. So we just dodged the problem. 4 times root 3, we just read that as 4 root 3. We already said the root 3 can only be said as the root 3, so 4 root 3. Pretty easy, huh? Let's look at some others. So like 2 over the square root of 5. All I'm going to do is take this denominator here, square root of 5, square root of 5, square root of 5 times square root of 5 is 5, 2 root 5. It's really quite easy once you get it, huh? So we can have like 3 over the square root of x even, just because, square root of x, square root of x, 3 root x over x. I'm not worried about all the other numbers and stuff going on. That's just, we used the properties to make it work for us. Let's try a few others, just to get more examples, right? Clear our page a little bit. So like 5 over the square root of 15. Let's do that. Square root of 15. Square root of 15. 5 root 15 over 15. Now, I did notice I can take this one step forward. 5 over 15. That would be 3. So it would be square root of 15 over 3. So we got the root out of the denominator. This is no longer there. We didn't like that. We put it up here, and that makes us happy. We can do, even if it was, as long as it's all under the square root, an expression. Like that. See how it's all under the square root? That's fine. I'm not worried about it. X plus 2. Awesome. The one time it doesn't work, or when it doesn't work, and we're going to have to add some other stuff called the conjugate, is stuff like the square root of x plus 4. See how this is not all under the square root. Then we can't do it. We've got to do something different. That's for we got to add a whole nother lesson or two until we get to that. So don't worry yet about this. Won't worry about that. Just make sure that the square root is on the bottom. If there is just straight multiplication, you can do it. So 3 over 2 root 5. You could just do the root 5 part. That makes your life easier. 3 root 5 over 2 times 5. The 2 just kind of comes through. 2 times 5, I think we can figure that one out. 5, that would be 10. So you can do that. But if there's the pluses and minuses outside of the square root, we can't do it. Those cause all kinds of troubles that we're not going to worry about today. I hope this was valuable and that you look forward to more lessons. And please comment or respond on what could help you better. And look forward to more fun. Thanks. Bye.